Hi, today let's talk about Hadoop rack awareness. So the agenda here is let's understand what rack awareness is, why it is important, what configuration options exist to enable rack awareness, and we'll also take a look at the flow of a write through a rack aware cluster and also the block placement in the rack aware cluster. The goal of rack awareness is to keep a rack from being a single point of failure. So again, if you look at the image here, a rack is just a big rack of servers, and here you can see that we have 6 individual 1 unit servers, 1 2 3 4 5 6, and 2 big servers here on the bottom. To see how a rack can be a single point of failure, let's say that we have 3 separate slave nodes inside of a rack. And though HDFS does give us the 3x replication to copy one individual block across 3 slave nodes, if each of those slave nodes existed in a single rack and then we lost power to that rack, we would lose the ability to recreate the file. Hadoop would think we lost all copies of that block. We didn't experience data loss, but we did experience a big inconvenience in that we can't recreate the file and we can't run any processing on that. To get maximum performance out of Hadoop, it is important to configure Hadoop so that it knows the topology of your network. If your cluster runs on a single rack, then there's nothing more to do, since this is the default setting. For multi-rack clusters, you need to map nodes to racks. This allows Hadoop to prefer within rack transfers where there is more bandwidth available to off-rack transfers when placing MapReduce tasks on nodes. HDFS will also be able to place replicas more intelligently to trade off performance and resilience. In a larger cluster of Hadoop, in order to improve the network traffic while writing HDFS files, NameNode, which is the master node of the Hadoop cluster, chooses the data node which is closer to the same rack or nearby rack to read or write request. NameNode achieves rack information by maintaining the rack IDs of each data node. This concept that chooses closer data nodes based on the rack information is called rack awareness in Hadoop. So why do we need rack awareness? In Hadoop, rack awareness is required for below reasons: to improve data high availability and reliability, to improve the performance of the cluster, and to improve the network bandwidth. Avoid losing data if entire rack fails, though the chance of the rack failure is far less than that of node failures. To keep bulk data in the rack when possible. An assumption that in rack IDs higher bandwidth, lower latency. To use rack awareness, we essentially provide Hadoop with a script that it consults on file write, which tells it which nodes live in which racks. Hadoop can then make an intelligent decision about spreading the blocks across 2 or more racks. And in this case, Hadoop will write a single block to one node in one rack, and then it will write all subsequent copies of the block to a second rack. So now we have no single point of failure. We can lose any single rack or the data nodes inside the rack, but we still have the ability to recreate the files and run processing on that. So let's quickly look at the rack awareness setup. To set up the rack awareness, we have to supply Hadoop's named machine. So this script takes multiple IP or hostname addresses and return a rack ID. There are 2 ways we can write this script. One way is to create the script by using a mapping file, which is just a static file where we specify individual servers, nodes, and the racks that belong. Here you can see that we went in and set up server 123. saying that it's in rack 1 and server 456 in rack 2. If we use the script, then every time we provision or deprovision a new node in the new rack, we have to go back and edit the script and update the entry. Or we can do it maybe more intelligent way by embedding the rack number into our host names, so that here our host names contain the rack number by default. So for example, here we have S123R1 indicating that this is the server 123 on rack 1, and similarly S456R2 indicating that this is the server 456 on rack 2. Going this second route means that we don't have to use this mapping file and have our script go and parse that file. Because we have to provision the host names already anyways, we are not adding additional work to our provision and deprovision process. So try to use the hostnames embed method. It's a whole lot easier in maintaining a mapping file, and you have to set up hostnames for each machines anyway when you're doing the Hadoop cluster setup. So to use the script file, you simply provide core-site.xml, which is one of the configuration files of Hadoop, with the full path of the script you're going to use in a topology.script.file.name parameter. The name node will now automatically become rack aware, and any file writes after that point will be guaranteed to be spread across 2 racks. HDFS does not go back in, however, proactively take any blocks that are stored in the system already and makes those rack aware. If you wanted to, for example, take any data that existed in HDFS before you provided rack awareness, you would need to go in and delete and then re-add those files after you have created this rack awareness script. So this has been rack awareness, and we're covered with rack awareness, which is why it's important, along with some configuration options and the flow of your write through a rack aware cluster. So by default, if no script location is specified, the default behavior is to map all the nodes to a single network called /default-rack. Last but not the least, let's look at the replica placement or the block placement via the rack awareness. So as you're aware, the name node or the master of the Hadoop cluster has the following mapping. So it contains a file to block level mapping, blocks to data node mapping, and data node to rack level mapping. So this data node to rack level mapping is used by the mapping file, which we discussed in the previous slide. In our current example, we have 18 node cluster, so 6 per each rack, 318. So if you carefully look at these block colors, took block A, block B, and block C and colored them red, green, and blue so that it's easy to understand the block placement. So if you carefully look at the pattern in the placement of the blocks in the diagram, what do you get? In a rack, all these nodes will be connected to something called as a rack switch. As you can see here, on top of every rack you have something called as rack switch. When a data node has to transfer the data within the rack, so let's say from within the rack 1 from data node 1 to data node 3, it will be very fast. But if the data node 1 has to send the data to the data node 4 in rack 2, so first the information has to go to the rack switch, and from there it has to go to the main switch, and from the main switch it has to go to the rack switch of rack number 2, and then the actual data node 4. So here we can see that it requires a lot of network resources, and data transfer is also slow because we are transferring the data between 2 racks and between 2 nodes. But if you want to transfer the data from data node 1 to data node 2, it will be faster as it's within the rack. Hadoop architects designed it in such a way that there is a trade-off between high availability and the data transfer times. Data is always placed in 2 racks. Please note this carefully. Data is always placed in 2 racks. So as you can see here, first replica of block A, which is red, is placed in data node 1 of rack 1, and the second and third replicas are placed on a second rack, but 2 different nodes, data node 5 and data node 6. Similarly, block B, which is green in color, the first replica is placed on data node 6 on rack 2, and the second and third replicas are placed in a different rack and different nodes, data node 7 and data node 9. Similarly, block C, the first block is in data node 8 within rack 8, and the second and third replicas are on rack 1 but on 2 different data nodes. So this placement of replicated block is always in the off the rack placement. In our case rack 2, the third replica is always on the same rack but on a different data. In our case rack 2, third replica is always on the same rack but on a different data node. If they place the third replica on block A in rack 3, there's again a network latency. So this is the trade-off the Hadoop designers have made. So remember, first block is always placed at random, second block is off the rack, and the third is on a different node but on the same rack as the second block. So that's it for today. If you enjoyed this video, please subscribe to the channel for more upcoming videos.